Hello everyone and welcome to another video. My name is Adam, and in this video we are going to be looking at the new import pin delay option inside of Presto. Now when you're working with high-speed circuitry, oftentimes you're going to have to worry about something called relative propagation delay. Or in general, you're going to need to be concerned about the timing or how long it takes for a signal to propagate from the driver to the receiver. And when you're working with ICs, you have to start to also consider the internal pin delay that it takes, from it to get from the silicon to the actual exposed pad on that IC. So what we have inside of Presto is the option to turn on pin delay and then use that information that you might already have in your design to also be calculated when you're measuring things such as the total propagation delay or relative propagation delay between signals. So let's go ahead and look at our Constraint Manager really quick. I have here, the DDR data byte 1, which is, bits 8 through 15. And I have relative propagation delays rules already set up. And you see that my tolerance here is 1.27 millimeters, which is a pretty tight tolerance. However, this is not considering any pin delays. And here you'll see that there's actually no pin delay entered for any of this, for this relative propagation delay constraint. And this is happening if I look at my design between this DDR chip here, U20, and my FPGA here, which is U2. Now, in order to import pin delay, we actually have two different ways of doing this. In both cases, the first thing we need to actually do is under Constraint Manager, go to Analyze, and then select Analysis Mode. And then in the electrical section here, we can turn on pin delay. Now, if you are using the propagation, if you are using time in your pin delay, relative propagation delay constraints, then you would need to care about the propagation velocity factor. But if you are only using length in your pin delay measurements, then you don't need to be so worried about this. So once we've turned this on, let's go ahead and click OK. And you'll notice that also this pin delay, pin 1, pin 2 here, the analysis mode has been turned on. So these used to be yellow, meaning that these are not turned on. Now they're green, now they are gray, which means that, it's taking into account any sort of pin delay information that might be entered for these components. Now, you'll notice that in Constraint Manager, you can actually type these in manually. So for example, these are going to be the two nets which I'm concerned about for my example here. So A9 and B9, this is DDR DQ9 and DDR DQ11. Inside of Constraint Manager, I could turn on, for example, a 1 millimeter pin delay on my pin 1, which is coming from U20, so the FPGA, that's actually the DDR chip. And now you'll notice that I am no longer meeting my relative propagation delay requirements, meaning that these two signals will arrive at the receivers out of sync. All right, so let's go ahead and delete this really quick. Now, entering all this information manually can be quite a hassle, and oftentimes if you're using a chip from a manufacturer, maybe you have a good relationship with, maybe they already provide you with that information, and then it's just a matter of inputting all of it. So rather than doing it by hand, what we can do is go to File, Import, and select pin delay here. Now what this will ask you to do is to select a pin delay file, and I already happen to just have one lying around. So let me just go ahead and navigate to that really quick. We'll talk about kind of the syntax of that file in a second, but what this does is, you can identify components by the reference designator and then their pins, and then type in what type of pin delay you want to add, what type of pin delay you want to add to those pins. If something's not looking correct, you can also manually override it. So if this isn't supposed to be in mils, you can do that. Right, so if this is in mils, You can just type that in here, and that will override your unit or any of these delays, right? Whatever you need to change, you can go ahead and do so from this table. So let me just change this back to millimeters really quick. And then when you're ready, simply just click import, and then it'll tell you if the import was successful or unsuccessful. So let's go ahead and close that, launch our Constraint Manager again. And here we see that these pin delays have automatically been added into our Constraint Manager, right? We can rerun this entire byte lane and see that now these two nets are no longer in sync, right? The other option that we have also is if I turn on my nets option here, and let's search just these two nets. So I'll highlight them, right click, show in search results. Oh, excuse me, not nets. I want pins. So if I look at just these two pins here and right click, show in search results, at the bottom here in the search results, if we scroll to the right, we have a section for the delay. And if I double click here, I can actually edit this value. So I can change this to, for example, 1.35 millimeter, and this one also to 1.35 millimeter. Once you're done, simply, we can verify if I go into Constraint Manager. Here you see that these values are now 1.35 millimeter and 1.35 millimeter. Now, the last thing that you might be interested in is, well, if you've gone through the, difficult process of entering all the pin delays for a component, maybe you want to also export that information. So under File, Export, we have the pin delay option. If we go into our session log, here we see that it says select a component. So I'll go ahead and select this U20, and then it's going to ask us how we want to actually export this. So I will call this file U20 pin _ delay. And then I will have this as a CSV format, and then include header, include units on each pin. That looks good. Let's go ahead and select export. And then if we want to view this, we can open our design directory. And if I scroll down here, here's my U20 pin delay.csv. Let's go ahead and open that. And here is what this pin delay file looks like. So what we have is, the pin delay is, simply just a header. We have to name the reference designator. So here it's ref.des U20. Device, this is the footprint name. So if you have, a component maybe which has different packages, right? Maybe a BGA package, maybe a QFN package. You can have both of those in the same pin delay file and then just match it, with the right device. And then you just list all of your pins as well as the pin delays with the units or without the units, both works, inside of this table, inside of this spreadsheet, or even a text file if you want to. So here's an example of what this would look like in a text file. Save it out as a CSV, and then simply import it back into your design, and then you will have pin delay working as needed. So that is it for this video, guys. Hopefully you liked this preview for 25.1 in Presto. If you have any questions or comments, please feel free to leave them below. Or if you have any recommendations on what you'd like to see in a future video, please let us know as well, and we'd be happy to make some videos in the future. Again, thank you so much for watching. Hopefully you guys liked all of these previews that we've been working on for our 25.1 release in September. And yeah, I will see you in the next video. Bye-bye.